For years, the electric vehicle industry believed it had reached a limit. Engineers from the world's largest automakers accepted that every electric motor required a compromise. If a vehicle delivered incredible acceleration, it usually sacrificed efficiency and driving range. If it prioritized long-distance travel, it often lacked the explosive performance drivers wanted. This trade-off became one of the few rules almost everyone accepted. Companies spent billions improving batteries, refining software, and redesigning vehicles. But the basic limitations of electric motors seemed impossible to escape. Tesla never completely accepted that idea. Instead of focusing only on building bigger batteries or adding more horsepower, Tesla's engineering teams quietly began studying the electric drive unit itself. Their goal wasn't simply to build the fastest motor on the market. They wanted to create something smaller, lighter, stronger, and more efficient all at the same time. Most experts believed that achieving all four goals together wasn't realistic. Every improvement in one area usually created problems somewhere else. But inside Tesla's research and development facilities, engineers continued searching for a different solution. At first, very few people outside the company paid attention. Public attention remained fixed on Tesla's vehicles, software updates, battery technology, and autonomous driving ambitions. Yet hidden beneath the floor of every Tesla was a component that received almost no headlines: the electric drive unit. While competitors concentrated on matching Tesla's battery range, Tesla engineers were quietly reinventing the machine that transforms electricity into motion. To understand why this matters, it's important to know how an electric vehicle actually works. Unlike gasoline-powered cars that rely on hundreds of moving engine components, electric vehicles use electric motors that convert electrical energy directly into mechanical force. Fewer moving parts mean less maintenance, smoother operation, and instant torque. But designing an electric motor that remains efficient at extremely high speeds while producing enormous power is one of the hardest engineering challenges in the automotive world. As electric motors spin faster, enormous forces begin acting on every internal component. Heat increases rapidly. Mechanical stress rises dramatically. Even tiny vibrations can become destructive at very high rotational speeds. Engineers have to carefully balance strength, cooling, efficiency, durability, and manufacturing cost. Improving one characteristic often makes another worse. For decades, manufacturers accepted those limitations as unavoidable. Tesla believed they could redesign the entire system. Rather than making gradual improvements to existing designs, Tesla engineers examined every part of the drive unit from the ground up. They looked at materials, cooling systems, magnetic fields, manufacturing techniques, and rotor construction. Their objective wasn't merely to beat competitors in performance tests. They wanted to create a motor that could be produced in large numbers without becoming prohibitively expensive. That challenge proved even more difficult than building a powerful prototype. Many companies have demonstrated impressive electric motors inside concept vehicles. Building one experimental unit in a laboratory is entirely different from producing hundreds of thousands of identical motors that must survive years of everyday driving. Manufacturing consistency often determines whether a technological breakthrough becomes a commercial success or remains an engineering curiosity. Tesla understood this lesson early. The company had already experienced enormous production difficulties while scaling earlier vehicles. Factory bottlenecks, supply shortages, and manufacturing delays taught Tesla that innovation means very little unless it can be built efficiently at mass production scale. Every new technology had to be designed with manufacturing in mind from the very beginning. This philosophy eventually shaped one of Tesla's most significant engineering achievements. Instead of accepting traditional compromises, Tesla developed an advanced electric drive system capable of operating at remarkably high rotational speeds while maintaining exceptional efficiency. One key innovation involved strengthening the rotor, the rapidly spinning heart of the electric motor, using advanced carbon fiber reinforcement. This approach allowed the rotor to withstand extreme mechanical forces that would challenge many conventional designs. The result wasn't simply a faster motor. Higher rotational speeds allowed Tesla engineers greater flexibility in extracting performance while maintaining efficiency. Better thermal management reduced wasted energy. Improved mechanical stability minimized vibration and stress. Combined with sophisticated electronic controls and optimized power delivery, the drive unit demonstrated that high performance and high efficiency no longer had to exist at opposite ends of the engineering spectrum. When experienced automotive engineers began examining Tesla's newest drive units, many were surprised not because of one revolutionary invention, but because of how many small innovations worked together as a complete system. Tesla hadn't broken the laws of physics. They had simply found smarter ways to work within them. And that realization sent a powerful message throughout the global automotive industry. Tesla's breakthrough didn't happen because engineers discovered a completely new type of electric motor. Instead, they reimagined how existing technologies could work together more effectively than anyone had previously managed. Every component inside the drive unit was carefully optimized to improve efficiency, durability, and performance without making the system too expensive for mass production. One of the most important innovations involved the motor's rotor. The rotor is the rotating component inside an electric motor that generates motion through electromagnetic forces. During operation, it spins at incredibly high speeds, sometimes exceeding 20,000 revolutions per minute in high-performance applications. At those speeds, the centrifugal forces become enormous. Without sufficient strength, the rotor can deform, lose efficiency, or even fail under extreme stress. Tesla addressed this challenge by introducing a carbon fiber sleeve around the rotor in the drive unit used in the Tesla Model S Plaid. Carbon fiber is widely recognized in aerospace and motorsports because it combines exceptional strength with extremely low weight. By wrapping the rotor with this material, Tesla engineers created a structure capable of handling far greater mechanical stress while maintaining precise balance during operation. This wasn't simply about making the motor stronger. The carbon fiber sleeve also allowed the rotor to spin faster while maintaining stability. Higher rotational speed meant engineers could generate impressive performance without dramatically increasing the motor's overall size or weight. In engineering, reducing weight while increasing performance creates benefits throughout the entire vehicle. Smaller motors require less cooling, improve efficiency, and free up valuable space for batteries or passengers. Cooling itself became another area where Tesla focused heavily. Electric motors naturally generate heat whenever electricity flows through them. Excessive heat reduces efficiency and shortens component life. Most manufacturers rely on larger cooling systems to remove the heat, but larger cooling systems add weight, complexity, and manufacturing cost. Tesla instead worked to improve efficiency inside the motor itself. When less energy is wasted as heat, the cooling system doesn't have to work as hard. That creates a chain reaction of advantages. Smaller cooling components reduce vehicle weight. Lower weight improves acceleration and driving range. Better efficiency means more of the battery's stored energy reaches the wheels instead of being lost as heat. This philosophy reflects a principle Tesla has followed for years. Rather than solving problems by adding more parts, Tesla often redesigns existing components so fewer additional systems are needed. Instead of building around limitations, engineers attempt to eliminate the limitations themselves. Another key advantage comes from Tesla's integrated engineering approach. Unlike many traditional automakers that purchase major components from different suppliers, Tesla designs much of its own software, power electronics, battery systems, and electric motors together. This allows engineers to optimize the entire powertrain as one unified system instead of treating each component separately. For example, the inverter, which converts direct current from the battery into alternating current for the motor, is specifically tuned to match Tesla's drive unit characteristics. Software continuously adjusts power delivery thousands of times every second, ensuring the motor operates efficiently under changing driving conditions. The battery management system, cooling circuits, and motor controls all communicate seamlessly because they were designed to work together from the beginning. This level of integration gives Tesla an advantage that isn't always obvious from horsepower numbers alone. Performance isn't just about producing maximum power for a few seconds. It's about maintaining that performance repeatedly without overheating or reducing efficiency. Many high-performance electric vehicles can deliver incredible acceleration once or twice before thermal limits force the system to reduce power. Tesla spent years improving thermal management so its vehicles could sustain strong performance under demanding conditions. The Tesla Model S Plaid became one of the clearest demonstrations of this philosophy. Capable of producing over 1,000 horsepower and accelerating from 0 to 60 miles per hour in approximately 2 seconds under optimal conditions, it proved that an electric sedan could compete with some of the world's fastest production vehicles. Yet despite those extraordinary performance figures, it remained practical enough for daily commuting, highway driving, and long-distance travel. That combination surprised many industry observers. For decades, consumers believed they had to choose between speed and efficiency. Tesla showed that with careful engineering, advanced materials, intelligent software, and integrated system design, those compromises could be significantly reduced. But perhaps the most remarkable achievement wasn't the technology itself. It was Tesla's ability to manufacture these sophisticated drive units on a scale that most competitors were still struggling to reach. And that's where the real battle in the electric vehicle industry was only beginning. Developing an advanced electric motor is an impressive achievement. Producing millions of those motors efficiently, consistently, and profitably is an entirely different challenge. This is where Tesla has built one of its strongest competitive advantages, not just through engineering, but through manufacturing. In the automotive industry, history is filled with companies that introduced exciting new technologies only to discover that mass production was far more difficult than designing a prototype. A concept vehicle can impress audiences at an auto show, but building hundreds of thousands of identical vehicles while maintaining quality is where most manufacturers face their greatest obstacles. Tesla learned this lesson the hard way. During the production ramp of the Model 3, the company experienced what Elon Musk later described as production hell. Automated assembly lines failed to perform as expected, supply chains became overloaded, and manufacturing delays pushed Tesla to the edge financially. Those difficult years forced the company to rethink how vehicles should be designed for manufacturing rather than simply for performance. The experience permanently changed Tesla's engineering philosophy. Today, when Tesla develops a new drive unit or battery system, engineers consider manufacturing from the very beginning. Every component is evaluated not only for performance, but also for how easily it can be produced in large numbers. Reducing unnecessary parts, simplifying assembly, and improving automation have become just as important as increasing horsepower. This manufacturing-first mindset gives Tesla an advantage that isn't immediately visible to customers. Traditional automakers often rely on dozens of suppliers for major components. Motors may come from one company, batteries from another, software from another, and power electronics from several additional manufacturers. Coordinating all of these suppliers increases complexity and slows innovation. Tesla has taken a different approach. The company designs many of its batteries, power electronics, software systems, vehicle computers, and electric drive units internally. This level of vertical integration allows different engineering teams to solve problems together instead of waiting for outside suppliers to develop solutions. If improvements are needed in the motor, battery management software can be updated alongside it. If cooling requirements change, engineers responsible for the battery pack and drive unit can redesign both systems simultaneously. This integrated development process reduces delays and allows Tesla to optimize the entire vehicle as one complete system. Another major factor is manufacturing scale. Tesla operates some of the largest electric vehicle factories in the world, including gigafactories in California, Texas, Nevada, Shanghai, Berlin, and other facilities supporting battery and component production. Each new factory incorporates lessons learned from previous production lines, gradually reducing manufacturing costs while improving efficiency. Scale matters because fixed development costs become much smaller when spread across hundreds of thousands or even millions of vehicles. This allows Tesla to invest heavily in research while continuing to lower production costs over time. The company is also working to reduce dependence on expensive raw materials. In recent years, Tesla has announced efforts to design future electric motors that require fewer rare earth elements. Rare earth magnets provide excellent performance, but depend heavily on complex global supply chains. Reducing reliance on these materials could lower manufacturing costs while improving supply security. Similarly, Tesla continues researching ways to simplify power electronics and improve battery manufacturing. The company's 4,680 battery program aims to increase energy density while lowering production costs through new manufacturing techniques. Although production has faced challenges, the long-term objective remains the same: build better products that are also easier and cheaper to manufacture. This constant focus on cost reduction creates an important competitive advantage. When manufacturing becomes more efficient, Tesla gains flexibility. The company can reduce vehicle prices to increase sales, invest more money into research and development, or improve profit margins that help finance future technologies. Many competitors face a much more difficult situation. Several established automakers have invested billions of dollars in electric vehicle programs while continuing to balance traditional gasoline vehicle production. They must redesign factories, retrain employees, establish new battery supply chains, and develop software expertise, all while competing in a rapidly changing market. Newer electric vehicle startups face different challenges. Although many have introduced innovative products, scaling production requires enormous financial resources. Building factories, developing supplier networks, maintaining quality control, and producing vehicles profitably can take years, even for companies with excellent engineering teams. Tesla has already spent more than a decade solving many of those problems. That doesn't mean competitors cannot catch up. Companies around the world continue making significant advances in battery chemistry, software, charging infrastructure, and electric motor technology. The competition remains intense, with manufacturers in North America, Europe, South Korea, and especially China investing heavily in next-generation electric vehicles. However, catching Tesla requires more than matching one impressive motor. Competitors must build efficient factories, secure reliable supply chains, develop advanced software, improve battery technology, expand charging infrastructure, and manufacture vehicles at global scale, all while remaining financially sustainable. That is an extraordinarily difficult challenge. And Tesla believes its next advantage may come not from the vehicle itself, but from something even more valuable than horsepower. It comes from data, artificial intelligence, and the software that powers the future of transportation. When people think about Tesla, they usually picture electric cars. But over the last several years, the company's ambitions have expanded far beyond transportation. The electric motor inside a Tesla is no longer just a piece of hardware that moves a vehicle. It has become one part of a much larger ecosystem built around software, artificial intelligence, energy storage, and manufacturing efficiency. Every Tesla sold adds another connected computer to the road. Unlike traditional vehicles that receive only occasional updates, Tesla cars are designed to improve continuously through over-the-air software updates. Features can be refined, bugs corrected, and performance optimized without requiring owners to visit a service center. This software-first philosophy allows Tesla to improve vehicles long after they leave the factory. At the same time, Tesla collects enormous amounts of driving data from its global fleet. Cameras and onboard sensors record how vehicles interact with roads, traffic, weather conditions, and countless everyday driving situations. Before any information is used for training, Tesla states that customer privacy protections are applied according to its data policies. This real-world driving information helps engineers improve driver assistance features and develop future autonomous driving technologies. The more vehicles Tesla sells, the more driving experience the company can analyze. This creates a cycle that becomes increasingly valuable over time. Better vehicles attract more customers. More customers generate more driving data. More data helps engineers improve software. Improved software makes future vehicles even more capable. While other automakers are also investing heavily in artificial intelligence, Tesla has built much of its strategy around integrating hardware and software from the beginning. To process massive amounts of driving information, Tesla has invested in powerful computing infrastructure, including its Dojo supercomputer project. The purpose of Dojo is to accelerate AI training using video collected from Tesla's vehicle fleet. Faster AI training means engineers can develop and test improved neural networks more efficiently. Although fully autonomous driving remains an ongoing engineering challenge across the entire automotive industry, Tesla continues investing billions of dollars into the research required to reach higher levels of automation. But artificial intelligence is only one piece of the company's long-term vision. Tesla also sees energy as a critical part of its future. In addition to vehicles, the company manufactures large-scale battery storage systems designed to support renewable energy projects and electrical grids. Products like Megapack and Powerwall demonstrate that Tesla's expertise in battery technology extends well beyond automobiles. This diversification helps explain why improvements in electric motors remain so important. A more efficient drive unit reduces energy consumption. Lower energy consumption improves vehicle range. Better efficiency reduces operating costs for customers while allowing engineers greater flexibility when designing future vehicles. Small engineering improvements can produce significant benefits when multiplied across millions of cars. Manufacturing efficiency follows the same principle. Each time Tesla simplifies production, removes unnecessary components, or improves factory automation, the savings accumulate across every vehicle it builds. Over several years, these incremental improvements can become major competitive advantages. That philosophy has guided Tesla since its earliest days. Instead of searching for one revolutionary invention that changes everything overnight, the company often focuses on hundreds of smaller engineering improvements that work together. Individually, many of these innovations appear modest. Combined, they create vehicles that continue pushing the industry forward. Of course, Tesla's position is not guaranteed. Competition in the electric vehicle market has never been stronger. Chinese manufacturers continue expanding rapidly, introducing increasingly sophisticated electric vehicles at highly competitive prices. Established companies such as Ford, General Motors, Toyota, BMW, Mercedes-Benz, Hyundai, and Volkswagen are investing billions into next-generation electric platforms, battery technology, and software development. Every year, new technologies emerge that could reshape the competitive landscape. Solid-state batteries, improved charging systems, advanced semiconductor technologies, and next-generation manufacturing techniques all have the potential to influence the future of transportation. Tesla understands that maintaining leadership requires constant innovation. The electric motor that surprised so many engineers today may eventually be replaced by something even more advanced tomorrow. History has shown that technological leadership is never permanent. Companies that stop innovating eventually lose their advantage. That is why Tesla continues investing heavily in research, manufacturing, artificial intelligence, robotics, battery technology, and energy systems simultaneously. The company's newest drive unit isn't simply about building a faster car. It's about creating an engineering foundation capable of supporting the next generation of intelligent electric vehicles. Perhaps that's why Tesla's latest motor attracted so much attention from engineers around the world. It wasn't because the company had discovered magic. It wasn't because the laws of physics had changed. It was because Tesla demonstrated that many of the industry's long-standing assumptions could be challenged through better engineering, smarter manufacturing, and relentless optimization. Whether Tesla remains the industry's leader over the next decade remains uncertain. Every major automaker is racing toward the same future, and innovation is accelerating across the entire automotive world. But one thing is already clear. The electric vehicle revolution is no longer about replacing gasoline engines with electric motors.